I'm Anil Kumar, and in this video we will see how to convert Cartesian or scalar equation in R2 in different forms, which are vector, parametric and symmetric. So the question here is, write vector, parametric and symmetric equations for the line 3x minus 2y plus 6 equals to 0. Now there are different ways of doing it. I'll actually show you two different ways. One is the standard method. So this is normal method, I should say standard, which is normally adopted. Now the standard method is isolate y. So we'll begin with the equation 3x minus 2y plus 6 equals to 0. So you can isolate y. You can write 2y equals to 3x plus 6 and y is equals to 3 divided by 2x plus 6 divided by 2, or you say y equals to 3 over 2x plus 3. Now if you compare this with the equations you do in slope-intercept form, which you had been doing so far, you will say 3 over 2 is your slope, right? So we say slope m is 3 over 2, right? In vectors, this slope could be written as a direction vector. So let me write down direction vector here. Direction vector d as that is change in y over change in x. So we always write x first, so which is 2, and then y, which is 3. Right? So it actually helps you to relate slope, which you've been learning so far. Now direction vector, right, which is 2, 3. Now you get the direction vector. Now to write this in vector form, you need a point also. Preferred point will be x or y intercept. Since we already have this, right, so we could select x as 0 and we get y as 3. So we have y intercept, so that is, in this case, y-intercept is a good point, which is on the line, so which you could get by substituting x as 0 here, right? So x equals to 0, solve for y. So you can see that the y value is 3. So y value is equals to 3. So once you know a point and a direction vector, you can always write the vector form of the equation, which could be xy equals to the point, which is 0, 3 plus parameter t times 2, 3, right? Where t belongs to real numbers. Okay. So that becomes your vector form of the equation, right? So this is the vector form. Okay. So that's one way of doing it. So in this fashion, what you do is you kind of relate with what you've already learned, slope-intercept form, and then do it, right? The other method could be that we could find the intercepts. We could find intercepts. Now, let us find both x and y intercepts for the given equation. The equation is 3x minus 2y plus 6 equals to 0. To find x-intercept, what do we do? To find x-intercept, we'll say y is equals to 0. So when I say y equals to 0, I get 3x minus 0 plus 6 equals to 0. And from here we can solve 3x equals to minus 6. X is equals to minus 6 divided by 3, which is minus 2. Right? Similarly, we can find y-intercept, which is x equals to 0. So if I write x equals to 0, I get 0 minus 2y plus 6 equals to 0, or 2y equals to 6, y equals to 6 over 2, which is 3. So I get y-intercept as 3. Now, these two x and y intercepts give us 2 points basically, right? So we can say point A for us is, or we can say OA, which becomes the position vector, will be let us say one of these, let's say X-intercept, which is 0, minus 2, right? 0, minus 2. And then say OB is the other intercept, which is X value 0. I'm sorry, the first one was Y was 0. And X-intercept, let me write down, let's make this 3 now. Okay. The Y-intercept I'm writing as A, 0, 3. And let this be point B. Let this be point B. Okay. We're taking this as A, right? Okay. So OP will be the point OP, position vector OP will be Y is 0, X is minus 2. So minus 2, 0, right? Now once you have these 2 points, you can find the direction vector D, right? So D is difference of these two, which you can say as OA minus OB, right? So this will be OA 0, 3 minus 2, 0. And that gives you, this is 2, and this minus this is 3. So you get same 2, 3, right? So that's your direction vector. So once you have a point and a direction vector, you could write the equation, right? So you could get different equations. Last time we used Y-intercept. We can also write the same equation with X-intercept. So this time, let me write this equation with X-intercept. Xy equals 2. The X-intercept, which is minus 2, 0, plus T, 2, 3, where T belongs to real numbers, right? So that is another way by which we can find the equation in vector form, right? So, well, both these ways we just utilize to find equation in vector form. Now, here is another alternative to find equation in vector form. Let me call this as method 3. Method 3, right? Okay, so I have the equation which is 3x minus 2y plus 6 equals to 0. Whenever you're given equation in symmetric form, we can directly read the normal to the line from here. So let me put this in red. Normal vector here will be 3 minus 2. 3 minus 2. Now if normal is 3 minus 2, then the direction vector is what? Direction vector is, flip this, we get 2 and then 3. Change one sign. So here 1 is negative, we are making both positive. So we have changed one sign, right? Well, you can verify that the dot product of these two will be 0. So they are perpendicular, right? So that becomes your direction vector. So once you get the direction vector, it is easy to write down the equation by finding x and y intercept. So I'll not get into the details again. Follow these steps to find x, y intercept, any one of them, right? So in this case, it is convenient to find y intercept, for example. Suppose x is 0, y intercept is 3, right? So you can say x equals to 0, y equals to 3. So then you can easily get your equation, which you got earlier. And so let me rewrite the equation once again, which is xy. So this is a third method which you just learned of finding, but this is kind of faster than previous two, right? So it is 2, 3. Anyway, so these are 3 different ways of finding vector equation. Now, the real question was to write all the 3 forms, parametric and symmetric. So let's do that. Okay, so parametric is simple. X value is equals to 0 plus 2t, right? 0 plus 2t, and the y value is 3, this 3 and 3t, 3 plus 3t. So this is your parametric form. I know you need not write 0, just write 2t, but this gives you parametric form. Okay. And to get to symmetric equation, we only have to isolate t. So from the first equation, we can say t is equals to x divided by 2. From the second equation, we can get, which is this one. Let me write here, show you the steps. Okay, so we'll do y minus 3 equals to 3t, right? So what I'm doing here is I'm trying to isolate t to get you the symmetric equation, right? So we can do y minus 3 divided by 3 equals to t. Now both these t's, the parameters, are same, right? These two are same. So we could write x over 2 equals to y minus 3 over 3. So that becomes the symmetric form. Is that okay? So that is how we can very easily convert from one form to another, right? We could have written symmetric form directly from the information which we already have, and that is the vector equation information. Symmetric form can be written as x minus x0. Let me write down general equation so that you can do it directly without doing all this. X minus x0 over d1, right? So the direction in x direction, right? 2 in this case. Do you see that? And y minus y0 over d2, where what is d1, d2? When we say d, we could say this direction vector as d1, d2. Is it okay? So these two, right? So which was 2 and 3. So this is 2 and 3. Do you see that part, right? 0 and 3. This is minus 0, minus 3. So you could get direct also. So it's not very difficult. Practice, and I hope that becomes simple for you. We'll take few more examples in translating these equations from one form to another. I'm Anil Kumar, and I hope that helps. Thank you, and all the best.